Hello everyone. In today's video, we're going to use Subassembly Composer to design our side slopes using multiple targets. The technique we're going to employ today is what I call the cascading decisions. So what we have is an existing ground surface target, you can see here, and I also have a right-of-way offset target. If I zoom out, you can see it up here. So these are our two variables. We want to consider the surface target for cut and fill, but we also want our side slopes to consider the offset right-of-way target and not go outside it. So let's take a look. I've already started here and I didn't want the video to be so long. But what I have is I placed a point at the origin and then I placed a series of 4 auxiliary points in a row. So this is a classic go out and see if a target is available and then come back and do something. So what I'm doing here is I set an auxiliary point at a shoulder. You can see this is just a 3% for 10 feet. And then I do a V-ditch with a 2-to-1 slope on both sides. And then last, I seek the target surface, e.g. at 33% or 3-to-1. Okay? If that's successful, I want my decision to come back and do something. So let's take a look at the decision. What I'd like to do is I would like to decide, okay, is the EG above or below AP3? That'll tell me if I'm in cut or fill at AP3. And then also, I would like to decide, is the right-of-way outside of this daylight point, AP4 or P5, or is it inside? So that's my criteria. So in my mind, the first thought process for this decision would be this, what you see on the screen. I'm going to look at AP3 and see if the distance to the EG surface, you can see the target surface name EG, is less than 0, meaning below the surface, and that right-of-way offset value is greater than the offset value of AP4, the auxiliary point. If those things are met, go ahead and place, as you can see what's happening here, on the true side of the decision, go ahead and place the shoulder, the V-ditch, and the catch slope at 3-to-1, and place all real points and links. So that's working great. But what about the false side? So let's say, what if AP3 is above the surface? Notice nothing is created. And if you notice on the false side, I actually have a link and a point at a 3% slope for 12 foot. So I have a shoulder already started on this side. So what's the problem? Well, the problem is AP4. Because when the surface is below AP3, AP4 is not formed because the target is not successful. Remember, our decision criteria said that AP3 is below the ground, that's fine, but AP4 offset needs to be less than the offset of the right-of-way. Well, AP4 doesn't exist if the surface is down here. So we can't do that. So what I'm going to do is I'm going to highlight the end, and I'm going to copy that out. I'm going to remove the parentheses now. I'm going to simplify my decision just to look at the existing ground. Notice you can immediately see that shoulder on the false side begin to create the 3% for 12. Problem is my right-of-way. It's not going to consider the right-of-way the way I would like. Notice here is the right-of-way even in cut. When the right-of-way moves in, it does not consider and stop these from forming. So my catch slope or my daylight is outside the right-of-way, which is what I don't want to happen. So now we're going to employ what I call the cascading decision. I'm going to delete the true side and I'm going to place another decision. I'm going to connect here, true side, and then I'm going to connect true down here. So now let's review. The first decision only looks at AP3 relative to the existing ground surface. Is it above or below? Great. The second decision, we're going to copy in or paste in our offset criteria. So I'm going to remove the parentheses. So now I'm going to say if AP3 is below the surface, AP4 can form. It may not be in the right spot relative to the right-of-way, but it can form. So now I can do my test. So I'm cascading these decisions. So I'm saying if it's in cut, and if the right-of-way offset is greater than that, do the following, which I already had created. So now let's test in a field situation. Notice the false side is working. So now I can continue with some false testing to see how I like to evaluate my field slopes. Before I do that, I do need one other item, because even if I'm in cut, notice if I come inside of AP4, this turns off like I would like it to, but I still don't have a catch-all for this cut situation where the right-of-way is close. So what I can do is drag a point here and connect it to the false side here. Try again. And now I could maybe say slope to surface from P1. I'll just do a catch-all 2-to-1 slope, and I'll seek EG. So there you can see if my right-of-way is close in here, I'm still in cut, but the right-of-way is too close, I'll just do a simple 2-to-1 catch-all. Now we can start on the false side, or the field slope condition. What I'm going to do now is move ahead, just to save some time, to a subassembly that's already created with the field side. So this is exactly what you saw before, my two decisions. And then on the false side here, when I'm in field, I placed a shoulder, and then I placed an auxiliary point. You can see it on the screen, AP5. Then I did a decision to look at AP5 relative to the offset. If the right-of-way was outside of AP5, I went back in the true side and just placed a slope to surface at 4-to-1. So the next condition, when I run through the false, I wanted to look at my next scenario, which was a slightly steeper slope to take into account a tighter right-of-way. So I placed an AP6 point, an auxiliary point, and I placed that at 3-to-1. And then I went into another decision. Is the offset of right-of-way greater than the offset of AP6? If it is, and it's less than AP5, you'll get the 3-to-1. If it goes beyond AP5, now you have a 4-to-1. But what if it comes inside of AP6? You can already see I have a condition for that. That is the last decision after the true. I place AP6, and if it is false, I say just give me a catch-all field slope of a -2-to-1. And you can see if I go back to cut scenario, how it responds. So let's test in Civil 3D. I'm going to insert the subassembly. Refresh the image. Now place it just on the right side. So I'm going to hit left click once. Try that again. Place here. Escape. Now we need to go into my corridor. I'm going to right click, and I'm going to select rebuild all. Then I'm going to right click and go to properties, set all targets. We need to set my EG target, of course. But we also have a right-of-way target, which we set up. We're going to select this from a drawing. Feature line survey figures polyline, select from drawing. I actually have a polyline representing this test scenario for the right-of-way. Just drew a polyline in the file. Okay, you can see here is our slider where we are on this section here. So you can see I'm in a simple fill slope here. Let's move up closer to cut. I'm sorry, simple cut slope. Move up here closer to fill. So now you can see that I formed my ditch. Let's test my right-of-way. Move it in. So you can see as we move the right-of-way in closer, the ditch did not have room to form. So we went to our simple cut slope, and we move it out. We get our ditch again. Let's move our slider along because we go into fill. Our green line is our existing ground surface, so we can see our fill slope. Now let's move our right-of-way in on the fill. You can see the slope steepen up because of the right-of-way restriction. So my goal today was to show how cascading your decisions in Subassembly Composer can assist when you're trying to consider multiple targets or multiple variables in your side slopes. I hope this has been beneficial. Have a great day.